guys, and welcome back to a new video. So in this video we are going to learn about multispectral imagery. So until now we only worked with a kind of dataset that contain a single band. So if I open the DEM we previously worked with, so this is the DEM we earlier worked with. So if I go to the properties of the dataset, here under the source tab, here it says under the raster information, number of bands is 1. So that means it's a single band imagery. But today we will work with the kind of dataset that contain multiple bands. But before doing that, let's learn some key things about the multispectral imagery. So multispectral imagery plays a crucial role in the field of geographic information system by providing a richer and more detailed view of Earth's surface compared to a traditional single band images. Multispectral imagery involves capturing data across multiple discrete spectral bands, each of which represent a specific range of wavelengths of electromagnetic radiation. So this band can include visible light, infrared and other parts of the electromagnetic spectrum as well. So here is the few basic things about multispectral imagery. So the spectral bands. So multispectral imagery consists of several spectral bands, each capturing information from a different part of electromagnetic spectrum. So the common bands include the visible spectrum. So these are the red, green and blue. Then the near infrared or NIR, then the shortwave infrared or SWIR, and thermal infrared as well. So in this picture what you are seeing is the entire electromagnetic spectrum. So this is the entire electromagnetic spectrum. So it contains gamma rays, then X-ray, then ultraviolet, then this is our visible spectrum, then the infrared, microwave, radio wave and long radio wave as well. So and all the colors we human can see falls between this visible spectrum. So there are only three main colors, that are red, green and blue, and all the other colors we see are the byproduct of the different mixing ratio of this red, green and blue color. So let me explain. So right now the color is black here, and if you guys can notice the RGB value are 0, 0 and 0 as well. So if I change the value of the red channel here, that is the red band, so if I change the value to 255, now the color is red because the value of the red channel is 255 and the green and blue both are 0. Now if I change the green value as well here, you can see the color is now changing. It's yellow now. Now if I change the blue value here, you can see it's a different color now. It's changing. Now if I change the red value here, look, the picture is changing. So basically you can create all the colors you want from red, green and blue. So the basic three colors are the red and then the green, then the blue, and by combining those three colors in a different ratio, you can produce all the color you want. So here it says in a color picture each pixel has three values. Those are red, green and blue. But in the multispectral imagery, there can be many more. In fact, there is many more, because there can be many more bands than red, green and blue. Now we will see applications in GIS. So the land cover classification. So multispectral imagery is used for land cover classification, distinguishing between different types of land cover such as forest, water bodies, urban areas and agricultural fields. Vegetation health analysis. So the near infrared and the short wave infrared bands are particularly useful for assessing the health of vegetation. So the healthy vegetation reflects strongly in these bands, allowing for the detection of stressed or diseased plant. Then the urban planning. So the multispectral data can aid in urban planning by identifying land use pattern, tracking urban sprawl and monitoring changes in the infrastructure. Environmental monitoring. It is valuable for monitoring environmental changes such as deforestation and wetland changes and assessing the impact of natural disaster. Precision agriculture. Often farmers use multispectral imagery for precision agriculture, optimizing crop management by identifying area of stress, nutrient deficiency and irrigation needs. So the remote sensing platform. So the satellites. Multispectral imagery is often collected by Earth observing satellites such as Landsat, Sentinel and MODIS, which provide global coverage at regular intervals. Then the aerial imagery. Aircraft equipped with multispectral sensor can capture high resolution imagery for localized project and specific applications. Drone. So the UAV equipped with multispectral cameras are increasingly used for small scale and high resolution data collection. Then comes the data processing. So the image pre-processing. This involves radiometric and geometric correction to enhance the quality and accuracy of the imagery. And image fusion. So combining multispectral data with other sources such as LiDAR or thermal imagery can provide more comprehensive information. Image classification. Utilizing machine learning and GIS techniques to classify different land cover types or detect specific feature within the imagery. So what are the challenges? Data volume. Multispectral imagery can generate large datasets that require substantial storage and processing capabilities. Atmospheric effects. Atmospheric interference can affect the accuracy of multispectral data and may need to be corrected during the pre-processing. Cost. Access to high-resolution multispectral imagery, especially from commercial satellite, can be costly. So in summary, multispectral imagery is a powerful tool in GIS, enabling the extraction of detailed spatial and spectral information for a wide range of applications from land cover classification to environmental monitoring and urban planning. Integrating multispectral data into GIS workflow allows for more informed decision making and analysis in various fields. So let me remind you guys, although I touched the basic points about multispectral imagery, but I only scratched the surface. If you guys want to learn more, you can do so. Simply search in Google, and so then you can get the entire detail and the specific things about multispectral imagery itself. So before working with multispectral data, we need to acquire or download the data. So let's see how we can download the multispectral data. So we will go to earthexplorer.usgs.gov. So this is the initial interface. This is the interactive map portion here, and this is area where you can mention your lat long and all coordinates, or you can upload the KML or shapefile as well. So what you have to do is you just have to select an area of your interest, and you just have to click here, and your lat long will be populated automatically here. And from here there are three tabs around here. the date range, the cloud cover, and the result option. You can filter your result by date within this tab. Then the cloud cover. The cloud cover is a very important thing for the multispectral imagery, because cloud can affect the image itself. The higher the cloud cover is within your image, it most likely it's more biased. So in this case the less is good, so I will only select 0 to 5%, I guess, and we will go to the dataset tab. So if you guys can remember, so we downloaded our earlier DEM from here, digital elevation model, then SRTM, but in this case we will go to Landsat, and then we will go to Landsat collection 2 level 2, and we will select Landsat 89 OLI TIRS C2L2. So OLI and TIRS are those instruments that are installed in the Landsat satellite. OLI stand for optical land imager, and the TIRS stand for thermal and infrared sensor, and C2 means collection 2 and L2 means level 2. So we will go to result. So here are our results. So there are 272 results. These are the footprints. So this image is overlapping our polygon. So we will select this picture, and we can read the metadata from here. Let me show you the name. So this is the name of the product, but this is not a randomly generated name. This name has a specific meaning. We will learn about that later. So let me go to the metadata again. So this is the metadata, the path and the row. Then there is day night indicator, it's day because it's a passive sensor, and the land cloud cover 4%, scene cloud cover 2.67%, and the data type OLE TIRS L2SP. So the datum is WGS 1984, UTM zone is 30, and ellipsoid is WGS 1984 as well. So now we will download this data. Just simply click here, and what we will do is we will go to the product option here. You can either download this individual file, or what we can do is we can download the entire product as bulk. I will do that. I will download the entire product from here. If I click here the download product, the download will begin. But I have already downloaded the product, so I will not do that in my case. So after downloading the product, you will have a zip file like this. You just simply have to extract it, and you will get a folder like this, and this is your entire data. So there are text file, then there are the bands. You can see the T1 SR B1. So SR means surface reflectance, and B1 means band 1, then band 2, band 3, band 4, 5, 6, 7 aerosol, then the radiance band. So this is your entire product here. Now let me give you guys a sneak peek what we can do with this Landsat, I mean multispectral images. So we can add data from here. So in this case I will add only 2, 3 and 4, 3 bands here. So I will change the data frame properties from here to, I'll go to projected coordinate system, then UTM 1984 northern hemisphere, and I will select UTM zone 30. So although it's looking similar to the DEM, but it is not, trust me. If I go to the properties layer here under the source tab, although it says number of bands 1, this band is the part of the entire dataset. Let me explain you what I mean. So what I will do is I will go to the window, image analysis. I will select those 3 bands here and I will generate a composite. Now if I disable all 3 layers, you can see now the difference between this image and this image. It's different, right? It's colorful. So in the next video we will learn how we can create a band composite or layer stacking, and we will learn more about the naming convention of the Landsat image, and we will create some basic composite. So until then, goodbye everyone, have a great day.